Hi everyone, I'm Stephen Hailes. I'm the head of Departmental Computer Science, and I'd like to welcome you to our very first information session for robotics and AI. It's a new program that we're putting on, and it's a new campus that it will be put on at. And so it's really fantastic to see so many of you registered for this and people coming in, still coming in. The session's being recorded. You won't be able to speak here, but one of the things we'd like to do is be able to answer some of your questions, and we'll have a session later on. I'm going to give a short presentation to start with. We'll have a session later on where we'll answer some of your questions, and Lewis Griffin, who you can see, will host that session for us. So what I'm going to do is I'm going to start with a short presentation to tell you something about the area, and hopefully that will answer some of the questions anyway. This is a new program for computer science. Computer science has been around at UCL for more than 40 years. It started in 1980, and it's a new program actually for across the UK and largely worldwide. Actually, there aren't very many undergraduate degrees in robotics and AI. So I think we're at the start of a revolution here. Technology has changed the world, it's changed society really very fundamentally, but we're at the start of a revolution in intelligent robotics. Robots have been around for a while, but in the past, they've been limited to largely industrial applications and largely in places where there are no human beings as well. So arc welding and things like that. So robots have been put in cages in factories. And one of the things that we're seeing at the moment, and you can see behind Dimitrios in his background, is robots actually out in the wild in society. And there are an awful lot of application areas for robots now. So obviously transport, obviously autonomous vehicles, they're coming, and a lot of the technologies to make vehicles autonomous are in everyday vehicles these days anyway. Robotic surgery is here, it's being experimented with at the moment. Same for rehabilitation and physiotherapy and a variety of other medical applications. It's part of the military as well. So we're seeing the use of robots in bomb disposal, for example. We are seeing robots in factories, but we're seeing increasingly robots working alongside humans in factories as well. There's an interesting little robot down at the bottom there, which is a cleaning robot that also tells jokes. So it's used in hospitals for doing some of the cleaning, but it will also tell jokes to patients, in this case on a children's ward. In fact, not very far from where I live. We see robots in space, we see robots in really hostile environments. And so we see robots cleaning up the Fukushima nuclear plant, for example. We see robots in labs, we see robots in education. We're seeing robots delivering things from shops or from takeaway places. We're seeing robots in food production. And in the top left here, we've got an image that was, there was a big launch by Elon Musk in the last day of a humanoid robot that, it's a start. It'll take some development, but it's interesting that companies as large as those run by Elon Musk are getting involved in this space. So there's an awful lot of applications in the robot domain. And if I turn to AI, I mean, there are too many applications to list, to be honest. AI is applied in just about every aspect of life these days. And so I've listed a few on this slide, but I'm not going to go through them because it touches on just about everything we do. Where's this leading us? Well, is this purely academic? Well, it's not actually. If you look at the likely markets for robotics, then these are large now and growing significantly. So the figure to look at here is that 22.8% compound annual growth rate. So it means it will grow by a quarter every year compounded till 2030 and probably beyond that. But that's the prediction there. And for the AI market, we're looking at an annual growth rate of near 40% compounded every year. So these are enormous growing markets. And so the potential down the line is astonishing. Okay, so what I'm going to do is I'm going to turn to UCL and Computer Science, who we are now. So UCL was founded nearly 200 years ago. So if you come study at UCL, you will be here for our 200th birthday. And it's been a radical pioneering sort of a place. We were the first to admit students regardless of race or religion. We were the first to admit female students on equal terms to male students. And actually, UCL shaped the modern university. So we were the first university to have professors in law, medicine, architecture, chemistry, languages, things that you would expect to see in any modern university. Well, that started at UCL. We have our fair share of Nobel laureates, including one who was the father of fiber optics. And actually, Ambrose Fleming invented the thermionic valve. So he was at UCL. The valve predates the transistor, which predates the integrated circuit, which is how we're all here now. So what about computer science? So UCL is a very large institution. It's a multi-faculty institution. And we have everything from computer science to art to anthropology to all sorts of things. But what about computer science? Well, we're also quite a large department, large computer science department. We've got on the order of 130 academic staff, about 1,200 taught students at the moment, although that number will increase, in particular with this course. We run 700 or so projects for our taught students with industry every year, or external partners, I should say. We've got an awful lot of research going on, and that covers a very broad range of activities. So we do some foundational work in computer science, and we're very proud of that. But we also look at application areas that range from robotics and AI to financial computing, to medical imaging, and everything in between as well. So we're a very broad and very interdisciplinary department. That's reflected in our teaching. So our present taught courses at undergraduate level, we've got three. We've got a 3-year BSc and a 4-year MEng in computer science. We've got a much smaller 4-year MEng in mathematical computation. And clearly, we're about to start a new MEng program in robotics and AI. But at postgraduate level, we've got a very broad range of courses that we offer that match our research expertise. So one of the USPs for UCL is that we bring our research into our teaching, particularly into the later years of undergraduate programs, as far as you're concerned, but also into our master's courses as well. We have people in the department who are true experts in their field. This is what they do day in, day out. They push the boundaries. They are the disruptive thinkers of today. They're always looking at new technologies, new applications, and that deliberately feeds through into our teaching as well. So if you come to UCL, you will be taught by these people. What about our students? Well, our students also are amazing. We have fantastic students. And what I want to do is I want to show you some of the impact that our existing CS students have had. And so I'm going to show you something about motion input. So motion input's a project that's been joint with Intel and Microsoft and IBM, and in fact, actually also the NHS. And what you see on the right-hand side of the screen here is a tweet from Pat Gelsinger, who's the CEO of Intel. So the CEO of Intel is tweeting about our undergraduate students. So these are CS students, because we have CS students at the moment. But what I'm going to do is, and I hope it works.
My name is Paris, and I am a 31-year-old mother of 2. At the age of 26, I was diagnosed with MEng. So how am I playing video games with my children?
My name is Sinead, and I'm a computer science student at University College London. I came onto this project when Professor Dean shared his ideas on a project in which users could interact with digital devices without the need to use their hands.
Working as a professor of computer science, we were amazed by the technological advancements our students were making with motion input, and decided to invite mentors from Intel, IBM, and Microsoft to provide guidance which has proven invaluable.
He tasked us to create something that would really make a difference to people's lives. An application that could give those with fine motor skill conditions opportunities that typically able people take for granted. We knew motion input was the answer, but there were still so many questions. We agreed straight away that we needed this application to function universally on any Intel-based machine without the need to purchase expensive bespoke peripherals or alter third-party code. OpenVINO was the breakthrough. We settled upon a grid-based hybrid facial navigation technology that could trace the user's eyes or head movement to control the mouse pointer, whilst an action like opening or closing the mouth or raising their eyebrows could be mapped to a mouse button click. Motion input isn't just confined to facial movement. Hand gesturing using Windows touchpoints could be utilized anywhere from schools to hospital surgeries. With a simple Intel-based machine and webcam, motion input could lead to massively increased population health benefits, or even utilized in care homes where the elderly, who may previously have struggled with grasping objects with their hands, could play online games like chess with their friends or family.
Imagine you had a condition where you found physical movement challenging. Maybe you had a motor neuron condition, or were a patient confined to a hospital bed.
The potential for motion input to change lives is limitless.
So that's an example of the kind of impact that our students can have. I mean, this is a video produced by Intel. It's not one we produced, on the back of work done by our undergrads. We are starting, we've been innovating for a long time. We're actually starting a new campus at UCL. And one of the, these are pictures that I took 2 days ago, actually. The thing that UCL Computer Science is working on there specifically is robotics and AI. So we're growing a big, large, new robotics and autonomous systems group that will be housed on the campus at UCL East. And clearly we'll also be teaching there as well. So one of the things that I want to talk about, because I know I've been asked questions about this, is the Industry Exchange Network. So this is offering opportunities for our students, not just to do purely academic things, but to work with external clients. Now, not all of these clients are industry, although we do work with industry, both large tech industry, clearly, and small. But some of them are charities, some of them are the National Health Service in the UK, and a variety of external partners. We have, well, there's some of them, right? Really, it is a lot more than that, but there's a limit to what you can fit on a slide. So this is, again, a key USP for us. We are keen that our students actually get a taste of the real world as well. Briefly, I'm going to turn to the MEng in robotics and AI and explain a little bit about what's in this, and I'm happy to answer further questions on this. It's a newly designed course for us. And so what you see here is each of the years in turn. So we have the first year and the second year, and the next slide I've got the third and fourth year on. In every year, one of the things you will see is there is project work. So our aim here is specifically, we have taught courses, but specifically at the end of every year, or even throughout the year, to take the stuff that's in those taught courses and ask you to apply it for real. Now, this course is a mixture, actually deliberately a mixture of mathematics, computer science, artificial intelligence, and robotics. Now, what that means is, should you do this course, then you will get skills in each of these areas. Clearly, it's not a complete computer science course. So, for example, you won't do things on discrete mathematics, but you will do a lot more on continuous mathematics here. What we expect is those taking this course, and here's the third and fourth year, to be able to go on into fields that are numerate, into computer science jobs, into specifically into jobs with AI in them. And as I showed earlier, that's a very increasing number of jobs, and into robotics jobs as well. So it's not purely to educate people to go into robotics and AI, it's to provide basic skills that actually lead you into a whole variety of different careers, as we do on our undergraduate CS program anyway. And so what you see over this program is that it starts with foundational material and it moves forwards in terms of complexity and application. And so that's the reason that we have the courses in this particular order. There's not a lot of option in this course. It is as it is because we're drawing together multiple threads. And so there really isn't the time in the program to allow people to go off and do other things. And so that's, again, the reason it is as it is. As for our undergraduate computer science degree, we're expecting to offer the same A-level requirements here. So that's A star, A with A star in maths. 40 points at IB, with a total of 20 points in 3 higher level subjects, including a grade 7 in maths, and there are a couple of different variants of maths that you can use for that, and no score below 5. We do have contextual offers. So if you come from a socioeconomically deprived area, and you can find out whether that's the case by following that link, which I can put into the chat as well, then we do reduce our ask to A star AB, or 38 points at IB. So that's a drop from A star A to A star AB. The A star still has to be in mathematics. We still require a good level of maths. Nowhere, the only thing we require in this is maths. We don't require further maths. We don't require computer science. We don't require anything other than an A star in maths. What about employment prospects? What about prospects off the other end of this? Well, if you look at the reported salary from our computer science graduates, the mean at the moment, and I looked it up earlier, is £53,000 a year. So that's a mean starting salary for our undergraduates. There will be career support during your stay here. And another thing that we are keen to promote is entrepreneurship. And so there are entrepreneurship schemes for taught students run by UCL as well. Okay, so how do you get here? What makes for a good UCAS application? There are many questions on this, and so let me answer them kind of up front. The A levels I've spoken about, and they're a given, right? But the other thing we need from you is a personal statement. What should be in a good personal statement? Well, the answer is it should be personal. It's called that for a reason. It should be about you. It shouldn't be a generic statement that you've drawn from, you know, the web. It should really be about who you are, what your passions are, why you want to do these courses. So why are you interested in this subject? Why are you interested in technology and the future of technology? Why do you want to be part of that? Your computer science, robotics, maths related interests and projects. So things you have done in that area already, but also other things you're passionate about as well. So again, going back, it should be about you. What are the things you care about? This should be things that aren't necessarily on the curriculum, because we'll be selecting from quite a large number of people, and everybody's been at school, everybody's done the curriculum at school. This should all be, a large chunk of it should be about what beyond that, above and beyond. So what beyond that do you do? What are your leadership roles? What are you really, really interested in? And how do you evidence that? What have you done to show that you are? It's very easy to say, I'm interested in this, but actually if you've done nothing in it, then there's no real evidence. It's just words. So it needs to be evidenced. So something about you, something about your passions, and the evidence that we can put to those as well, and it needs to be above and beyond. We do have some scholarships, in particular for people who identify as Black or mixed Black. And the reason we've started that is that there is very significant underrepresentation of Black students in technology and engineering, generally in computer science in particular at the moment. And so we have 3 studentships a year. They cover full tuition fees plus an annual allowance. And we can talk about the detail of this later. We have Kiran Ahmed with us, who's been intimately involved in setting these up. We're assisted by the Windsor Fellowship in these, in selecting the students. The scholarships that we have on offer are only available to offer holders. So you have to be an offer holder to be able to apply for the scholarship in the first place. Okay, I'm going to stop there. So thank you very much. And what we'll do now is we'll move to questions. I'm going to ask Lewis to chair this session, but we have a panel here that consists of some academics, some of our professional services staff, and some of our students as well. So we'll take questions of all types. So over to you, Lewis.
Thanks, Steve. Okay, we've got lots of questions here. I could go around the panel and introduce everyone, but I think I'll introduce people as we go. I'll start us with a nice, straightforward, kind of short factual question, which I think will be for Steve, which is, how many students do you expect to be taking on this program next year and in future years? And how does that compare probably to how many computer science students do we take?
Okay. Let me start with the number of computer science students we've got. So for our BSc and MEng course combined, we've taken on the order of about 140, 150 students a year. For the robotics course, what we're aiming at is somewhere between 60 and 70 students a year. So we're aiming for it to be a little smaller. There's several reasons for that, but one is simply a practical reason, because there's quite a lot of practical activity in this, and there's only a certain number of people you can fit into a space making use of robots. And so, and also when it comes to projects, in third, fourth year individual projects, they're quite intense activities. We've scoped the size of the academic staff to be able to support about 60 people, 60, 70 people.
Okay, good, thank you. Right, now then there's a whole bunch of questions and some of the pre-submitted questions, which are, I can see people are trying to work out which program to apply for. They once upon a time, they might have been just applied for computer science. Now we've got this other thing on offer. And I can tell from some of the questions, some of the people are kind of thinking, well, I'm a bit in the middle. I'm actually, I would characterize my interests as machine learning and AI. And that's where I want to go ultimately. Should I go down the CS route or should I go down the AI route? So I think Marc might have some things to say about this, and then perhaps some other people as well. Well, what do you think people should study, or how should they go about trying to make this choice, Marc?
Yeah, hi everyone. My name is Marc Deisenroth. I'm a professor at UCL, mostly working in the machine learning area, but also in robotics. And I helped setting up this undergraduate degree, mostly the machine learning aspects. So coming back to the question, if you're interested in machine learning / AI, and not so much in robotics, and maybe this particular degree isn't the right choice for you, and I would then rather recommend going for a CS degree. But if you are interested at the intersection of robotics and machine learning / AI, then maybe that degree is exactly the right thing for you.
Okay.
I'd add something to that, actually. There's more AI baked into this course than you might find on our normal CS course. It starts earlier and it progresses through. As Marc said, that it's in the context of robotics, but there will be more AI.
We do have I would say we have an introduction to machine learning. We have a deep learning course, but I think in year 3 or 4 we also have a robot learning course where you apply machine learning methods specifically to robotics. But I would still stick to what I said earlier. If you don't want to do robotics, this course isn't for you, because you will do a lot of robotics.
So is a decisive thing here about whether you want to get your hands dirty or whether you want to just stick with a keyboard. If you need to want to build things, physical artifacts, and yeah, great. Okay, and people are also worried about, or people are thinking about, I mean, people are wondering about what the career prospects are here. Is one better than the other? Or Dimitrios, how do you think the employment prospects are for people in robotics?
Thanks, Lewis. So let me introduce myself. I'm Dimitrios Kanoulas, associate professor in robotics, working mainly with legged robots. And one thing to add in the previous conversation, there were some questions about different programs. Data science, some people mentioned. Mechatronics is the other, and the answer is that all these come into this program because robotics is something different than just mechatronics or just data science or just machine learning. It's a combination, basically, so they cannot work by themselves. So it is a little bit more than that. In my opinion, with this type of programs, because you see things from different angles and you get an idea about the whole system from the low-level controller of a robot, so how a motor is working, to how the robot is understanding the environment and is making ethical decisions about a task. This gives you so many options in later in your life on which direction to go. You can easily work in a purely robotics industrial setting, or an industry in robotics, or you can go in other directions. So ethics, you can go to vision. So you have so many alternatives. Even I would say machine learning fields that they may be a bit on the side of robotics. So I think it gives you a lot of options and a lot of directions, in my opinion. And this is what I've seen from people that they do robotics. It's not just one industry they go after that. It's not just one company. They go to multiple directions depending on their interests. Yeah, I hope I answered the question.
Well, you have, but I suspect this is something people are really interested in. So I'm going to also ask perhaps our students here to tell us, from their point of view, how much sort of access to AI and machine learning and even robotics topics are they able to get through the ordinary UCL Computer Science degree? Do Clarissa or Pom feel you could say anything about that? Who are you pointing at, Clarissa?
Oh, Pom, sorry.
Well, either of you might.
Yeah, I do think there are quite a few options to study machine learning in the regular degree. And that is during the, I think, 3rd and 4th years. There are a few optional modules that you can take that will cover those topics. But also there's a program called the Integrated Engineering Project or something like that. Yeah, and within those you can pick robotics, which will allow you to study a few modules in the robotics field. And that includes an introduction to robotics, medical and industry robots, and machine learning in robotics. So there are a few options in the regular course as well.
So you do get modules with artificial intelligence. There's artificial intelligence and neural computing, but it's not like a foundational part of the course. So if that's something like you're really interested in, you want to focus on, I definitely think this is what you should go. You should go for the new one.
Okay.
Yeah.
And then for Steve, people are asking, it's a popular question, is applying for both courses a reasonable thing to do?
It's certainly a possible thing to do. I think that that's an individual decision ultimately. But as far as I'm aware, this is something you can do. We will consider the applications for both courses.
Okay. So you kind of, they get considered separately. The fact that you put both in wouldn't affect the outcome of either of them. But of course, you've used up one of your options. And someone is also asking, we'll talk about personal statements in a bit. Obviously, you only get to write one personal statement, so it's going to be a little bit, you're going to have to sort of aim it somewhere between the two.
Yeah.
Good. I'm interested in the course itself very much. People are asking, there's some questions around access to research, getting involved in research, contact with research. There's been mention of projects. Are these kind of canned projects which are rerun every year, or are we imagining kind of more active ongoing research projects here? How much can students get in contact with real research going on in these courses? I'm going to ask again, I'll start with Steve and ask the others as well.
As I said in the introduction, one of our USPs is exactly that our students will be taught by researchers, and what we find on our existing degrees and what we expect to find on this degree as well, is that over time, the early projects that students get involved in are basically about building up knowledge and building up expertise. But over time, those projects become both more industry focused, so they've got real hard constraints from industry, and more research focused as well. So absolutely is the answer to that question. We not only offer it as an option, we expect it. We expect students to be involved with researchers and looking at pushing the boundaries. In the program that we have, the individual project is deliberately intended to be really quite a research focused project, but there are industrial projects and a group project as well throughout other years to cover other aspects of project work.
Super. Right, I see we've got a bunch of robotics research people here, and so I'm going to start with Simon Julia. Simon, if you could introduce yourself and then perhaps just talk about some of the robotics research that you're involved in at UCL, particularly in particular ones where students have managed to get involved in that research.
Well, thanks, Lewis. Hi, everybody. My name's Simon Julia. So yeah, I work in a number of areas associated with things like robotics and estimation. And yeah, very much to follow up, certainly the projects we all do, we do try to relate them with, in fact, a sort of research team associated with it. So I can give a couple of examples. At the moment, for example, I do a lot with the MSc, but we're planning to have similar projects in the undergraduate. And for instance, we've done a couple of projects with NASA. And what NASA is very interested in, and if I just flip my camera, this doesn't go horribly wrong, you might be able to see there, this is a simulation system called Chrono that's being used. And it's actually simulating the movement of, this is the Mars Curiosity rover. The colors you can see down there is it's measuring, representing the stresses that are going on there. Now, the problem you could see even with this short snippet of the video is this is really, 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 really slow to run. And so, for instance, one of the things that we're very interested in is, can you take real-time game engines, predominantly Unreal Engine 5, and actually use these things? And so, for example, one of the experiments we're doing with NASA is that we're actually comparing at the moment, I have been comparing the quality of, for example, physics engines in different games with the default physics engines that NASA uses, and if it's successful, they're going to switch what engines that they're going to use as a result. So that's a sort of one example of research question. Another example of research question, this is a CS undergraduate project that's going to be starting very shortly. Is the problem of putting a robot in a mine. And one of the interesting problems with that is when a robot drives around, it's got big lights on the top of it. Sorry, I have to move this. My desktop's not working properly. And what happens is when you move a little distance, all the lighting changes. So if you move a little distance, all the light changes. How can you track stuff stably with all those lights changing? And also, how do you model effects there? So if any of you are interested in things like stuff called nurse neural radiance fields, we're saying, okay, to what degree are these applicable, for example, in very dark environments? And how can you extract data from them afterwards to tell you things like how flat and shiny the surfaces are, how damp the surfaces are, the orientation of, planes of rocks and things like that as well. So that's an example of, I guess, a couple of projects that I tend to be involved with that. And both of them, as I say, these actually have direct kind of research stuff. And I guess the reason why we think that the research is valuable is even if you don't plan a career in research, all the skills you need to be successful in industry you have to do. So you have to, for example, have a very clear definition of what your problem is. You have to investigate existing techniques and work out what does and doesn't work. You've got to evaluate and say which technique is good and which technique is bad. And then finally, you have to tell people what you've done, because if you've done great work and no one knows that you've done it, it doesn't help anybody else as well.
Thanks, Simon. That was a really great answer. And I'm sure everyone listening, one of the things they've taken away from that is the enormous enthusiasm that UCL, the teachers you'll have for research and for telling you and getting you involved in that research. Great. Okay, let's move to some a different type of question here, which I can see is popular. Is people want to know about I think what they should be doing in terms of strengthening their personal statement and in terms of preparing for this kind of study. So people are asking about, what programming languages Should I be learning? Should I be doing some kind of robotics projects to talk about it in my personal statement? I'm going to go back to Steve there. I mean, what programming languages is the degree going to use, Steve?
So it'll undoubtedly use a mixture of programming languages. So it's likely to use C and Python and maybe others as well. To some extent, it doesn't matter terribly much. Ultimately, what matters is the ability to program. And different programming languages are different for different jobs, in different environments. But the way we construct programs and the mental processes that go into that is broadly similar. So in terms of a personal statement, does it matter particularly if you've got a bit of experience in, I don't know, programming in Java rather than programming in C? No, not at all. It's the thought processes that go into the programming that matter much more than the language you're actually using.
Okay. But it's probably a good idea in a personal statement to say that you have been doing some kind of programming. Just to say, I've never done it, but I like the sound of it. It's probably not wise. It's probably best to be.
It's best to be proactive here.
Right.
That said, quite a lot of the people who come on undergraduate CS programs have done little or no programming in the past. So of course you need to be able to expect that this is going to come up, and the further ahead of the game you can get, the better. There your life will be easier, but it's not an absolute essential.
Good, thank you. Here's a kind of counterpart question, which someone is asking, and a few people are interested in. What proportion of the course is mathematics based? Because I'm sure people are thinking, there's there's three ingredients here, and there's going to be programming. There's going to be there's maths because there's AI, and then there's the hardware side as well. How much maths? How important is maths going to be in this degree? Well, Marc, what do you think? How important do you think maths is, Marc, for?
I kind of expected that one is going to hit me. I think maths is extremely important, independent of what you study. So I believe this course has a higher maths, or maybe higher and maybe different maths component than a standard CS degree. The thing is that in order to do anything in machine learning, it would be great if you could, if you actually understand what you're doing instead of just plugging some software packages together. And that requires some solid understanding of maths. But the same is true also for other subjects that we teach, like estimation or control theory. So all of these will require some reasonable understanding in maths. And so there's also, I saw that earlier in the Q&A, kind of like, is this a CS degree? Is this an engineering degree? What is it? And it's kind of like both and neither. It's something special in the sense that it's somewhere between CS and engineering. So you get some components from CS, you get some components from engineering. And so I think the maths is more, I would say, is coming more from the engineering side. You will have CS components like algorithms, data structures, programming, obviously, and it's like somewhere like an interdisciplinary course, and it's in that sense I think it's actually quite exciting. There was also, sorry to just go on about this particular course. There was a question somewhere about women representation. So we don't have numbers for this yet for this particular degree because it hasn't started yet. Maybe Steve can give us some numbers on the normal CS degree, and then can continue about what we're doing about it.
There is underrepresentation of women in technology subjects generally, and computer science is no different there. UCL Computer Science has been involved in trying to redress this or address this for the last 10 years and more, actually. But we're still at around about 20% female in computer science. I wouldn't particularly expect it to be different for this, but as Marc said, who knows?
So I think we have a great opportunity with this degree to actually get this balance a bit better. We are working very hard in the CS department to encourage women to join CS degrees and also this particular degree here. We've just gone through a couple of months hiring processes for professors who are teaching in here, and ballpark, we're maybe ending up between 40 and 60% female representation in the new hires. So that is, I think, also a very great step forwards.
And Kiran, did you want to add anything on the question of representation within our student body?
Yes, I just wanted to add that we have a brilliant YouTube series called 10 Minutes with a Woman in Computer Science. So it'd be great for the participants to go on and see this and see what our students and staff are like. We also have a lot of schools outreach work and the ACOMPS mentoring program. So we are supporting students from underrepresented groups and also women in making a better application, UCAS application, and also applying to UCL. So we also have like a very active Athena Swan group, and we have a silver award in the department, and we're currently working towards a gold award.
Thank you. Okay, there's a bunch of questions which are popular. I'm not sure how useful the answers are going to be, but I think we need to try and say something. Steve, people are hearing that there's going to be smaller numbers on this course than CS, so they're wondering if it's going to be harder to get into. And they're also wondering about if they're applying to both types of course, how they should aim their personal statement. What's the kind of advice we can give people?
Okay, on the will it be harder to get in? The short answer is we don't know yet, because we don't know how many people are going to apply for the course. It's a new course, and so potentially, actually, it may even be easier to get in because it's a new course. So I can't offer any useful information on that. In terms of aiming the personal statement, between computer science and this, we're not really expecting people to have a vast amount of experience in robotics when they come on this, or AI or whatever. And so I'd go back to what I said earlier. I mean, tell us about you. Tell us about what you're really passionate about. I'd rather take people who, yes, are interested in the subject. They need to be interested in the subject. You need to tell us that you are and show us that you are, but that have done, things outside as well. Our only requirement at A level is an A star in maths. If you've got an A level in history, if you've got an A level in English, that's fine by us. Yeah, so broad range of interests is good. Yeah, it's about passion, leadership, yes, an interest in the subject, and what you have done that is out of the ordinary, that's beyond what you see in school. So irrespective of whether it's CS or robotics, we're looking for the same things.
Thank you. Simon, I see you want to answer the question on about year in industry or placement years. Can you speak to that, Simon?
Okay, so we don't have a year in industry option for this course at the moment. It's maybe something that we will look at introducing in the future, and we don't have a year abroad option for this course at the moment. Again, it's something that we may look at introducing in the future. We want to establish the program. We want to make the program work well, and then I think we'll look at introducing that. So at the moment, there isn't an option to do this. There's a however to this. The however is there's an awful lot of working with industry in this. Our students, and I'm sure our students can talk to this, our students are in significant demand for internships in the summer and so forth. A lot of our undergraduates do internships with industry across the summer. Maybe it's a good question to ask Clarissa.
Oh no, yeah, you're absolutely right. Yeah, I interned at Amazon this summer. Palm interned at Microsoft. A lot of our classmates are interning at like tech companies, but also AI and research, and people are doing research internships with UCL. Yeah, the opportunities with UCL are practically, I don't know, endless. It feels, for example, there's this actually, sorry, I know we're running out of time, but quick. There's this one company that had a drop-down menu for the universities you could come from. I thought was super shady. And I looked at the drop-down menu, and then, of course, like all the big universities are there, and of course UCL was there. So it's not like you're limited in any way.
There's a good question, but I think it answers itself from what we've heard. Atford has asked, I have a general passion for mechanics, electronics, and computer science, and how those integrate together in modern problem solving through robotics. Is this course for me? I think it clearly is.
It is, definitely.
Yeah, I mean, you know, I think that's a great description of who we're looking for, but you know, but wider people than that as well. Right. We've got. There's a question about accreditation. So at the moment, UCL Computer Science degrees, we've stepped away from accreditation. And am I right, Stephen, thinking that there's no plan for this attempt to get accreditation for this degree?
There's no plan for it. As Lewis said, we've chosen actually for our computer science degree courses to step out of accreditation. We were in the past accredited, we've stepped out of accreditation. The reason for that is that we felt they were misshaping our courses. We were required to do things in order to be accredited that we didn't believe were actually necessarily in the students' pedagogical interest, in their interests. And so we've elected not to be accredited here.
Okay, super. Right, I think just a final question, something which we haven't talked that much about, is how come this course is going to be based at UCL East? Is that because, you know, they need to put something there, or is there a real positive reason for it being at UCL East? What's all that about?
Okay, there's a real positive reason for putting it at UCL East. It's new space, and within that space, we're getting some purpose design space. It's really quite difficult to retrofit what is quite a practical subject into space in central London, which is typically quite cramped. And so it's a new campus, a new mindset, actually. So it's not just computer science that's going there. There's a whole variety of activities, some of them engineering, quite a lot of them engineering based. So for example, there's an activity in new battery technologies that will be based out there as well, that we'll expect to be working with. There's an activity in new methods of manufacturing that we expect to be working with. But there's a wide variety of cultural activities as well. And one of the things that we expect to see in robotics is robotics interacting with people more. And so an understanding of how that happens and the societal impacts of that, and the cultural impacts of that, is all part of a broader educational ecosystem that we're trying to build at UCL East as a whole.
May I add something there? There is also a question about how UCL East campus enables effective learning, teaching, and research of robotics. I have to say that in UCL East, in combination of what Steve mentioned before, we aim UCL East to be the center of UCL robotics, and there is a concept that we have this UCL Robotics Institute, which is basically all the roboticists of UCL that can be computer scientists, mechanical engineers, you name it. We all have a center now, and this center is UCL East campus, and this will work in order to gather all people in robotics that will work at UCL in one space where we can develop together, teach and do research in robotics, combining all these fields. I think, and I invite all the people attending the call today to go and search for UCL Robotics Institute, because you will see how many people we are there, and this brings a really nice cohort in robotics. Yeah.
I think UCL East is going to be a fantastic, exciting place to study, and a really nice environment as well. That's my personal guess. Right, we're at 1 o'clock. How do we wrap this up, Steve?
Well, I think we should probably draw it to a conclusion. I know we haven't managed to answer absolutely everybody's question, but hopefully we've given you a sense of what we're trying to achieve here. I think it's amazing. I think it's going to be extraordinarily exciting activity. I think it's incredibly powerful for the future. I can't imagine a future in which AI and robotics do not play a really significant part. And what we're trying to do on all of our courses, actually, but on this specifically, is to educate people who will become the leaders of that activity in the future, who will drive this innovation. So I think we should just close by thanking everyone. I'd like to thank everybody on the panel, particularly our students, for coming. Looking forward to seeing those applications coming in, and looking forward to starting this course very much. So thanks very much, everyone, for being here.